We have been given two formula, and we are supposed to show that these represent AP, arithmetic progression, and also we have to find out the sum of the first 15 terms in each case. Let's take the first formula. AN is 3 plus 4n. Here, the nth term is given by this magic formula 3 plus 4n. Here in this formula, n is the position or the location of the term. So if you substitute the value of n as 1, then we'll get the first term. If you substitute the value of n as 2, we'll get the second term, and so on. So let's create an arithmetic progression and let's check whether it is actually arithmetic progression or not. So let's substitute the value of n as 1. So a suffix 1, which will be the first term, that will become 3 plus 4 times 1. So it will be 7. If you substitute the value of n as 2, 4 times 2 is 8 plus 3, that will become 11. If you substitute the value of 3, 4 times 3, 12 plus 3 will be 15. N equal to 4 will become 4 times 4, 16 plus 3 will become 19, and so on. Is this an arithmetic progression? Let's check whether the difference between two successive terms is constant or not. The difference between 7 and 11 is 4. The difference between 11 and 15 is also 4. The difference between 15 and 19 is also 4. Since the difference between successive terms is constant, this is actually an arithmetic progression, AP. So having established that, let's see how we can calculate the sum of first 15 terms. Let us see what are the characteristics of this arithmetic progression. Well, first term is 7, that is denoted by A. The constant difference, the common difference between two successive terms, which is constant, uniform, that is denoted by D, which is 4. Difference between 7 and 11, 11 and 15, and so on. And here we want the sum of first 15 terms, so n is 15. So let us use the formula for sum of first n terms of an AP. So that will be this particular formula. We'll substitute the value of n as 15, A as 7, and D as 4. So after simplification, 2 times 7 is 14. 15 minus 1 is 14 times 4. So we'll get 56 plus 14, that's 70. And when we cancel this with 2, this will be 35. So 15 times 35, your answer is going to be 525. Let's see the second case. AN is 9 minus 5n. Again, we will use the same procedure. We'll substitute the value of n starting from 1. When the value of n is 1, this will become 9 minus 5 times 1. That's 9 minus 5. That will become 4. When n is 2, this will become minus 5 times 2. That's actually 10. So minus 10. So 9 minus 10 will become minus 1. 5 times 3 is 15. 9 minus 15 will become minus 6. 5 times 4 is minus 20. 9 minus 20 is minus 11, and so on. Here, the difference between 4 and negative 1 is minus 5. Difference between negative 1 and negative 6 is minus 5 again. And difference between minus 6 and minus 11 is again minus 5. So here also, the difference between two successive terms is constant. And this is also an AP. The first term, A, is in this case 4. The common difference D is negative 5. That's the difference between any two successive terms. And the number of terms, again, because we want to calculate the first 15 term sum, that's n equal to 15. Again, we will use the same formula, try to substitute the given parameters. N is 15, A is 4, D is negative 5. So 2 times 4 is 8, 15 minus 1 is 14 times negative 1 is minus 70. Minus 70 plus 8 is minus 62. So that would be cancelling with this 2. So minus 31 will remain. When we multiply that with 15, we will get an answer, negative 465. So the answer for the first part is 525. And the answer for the second part is negative 465.